Chapter 6, Section 3, Solving Systems Using Elimination, Part 2. We already know how to solve a system using elimination when both equations have a variable with the same coefficient, which means the number in front of the variable. But when they do not, we can still use elimination. Today we're going to learn how to multiply one or both of the equations by a constant so that we can add or subtract the equations to eliminate a variable, so just like what we did yesterday. So today we're going to be adding in one or two more steps to the process. I still personally prefer elimination. However, depending on the circumstance, you might choose one or the other of the types of ways that we have to solve systems. Once again, really quickly, the ways that we know how to solve systems, and these are all three ways now. Today we'll finish up elimination. So the first way that we learned is by graphing. You go ahead and graph both lines, and wherever those lines intersect, that would be the solution to the system. Using substitution, you solve for one variable, and then you plug that value in for into the other equation, and you solve for the variables that way. And then elimination we talked about yesterday, so today we're talking about the second part of elimination. If I asked you what is the solution of the system, use elimination, and then I give you the equations negative 2x plus 12y equals negative 30 and 3x minus 4y equals 17. Yesterday, it was really nice because we had one or the other that had, or both equations had either x or y with the same number in front of it. One could be positive and one could be negative, but we would have like 9x and negative 9x, or 12y and negative 12y. In this case, I don't though. So what I can do is I can take one or both, depending on the system that they give you. I can take one or both of the equations and multiply the entire thing by a constant, or just by a whole number. So if you look at the two equations, negative 2x plus 12y equals negative 30 and 3x minus 4y equals 17. If you look at the x's, I have negative 2x and 3x. In order to get the x's to have the same number in front of both of them, I would have to multiply both of the equations. I would have to multiply the top one by 3, the bottom one by 2, which would give me 6x. But if you look at the y's, I have 12y on top and a negative 4y on the bottom. 4y could go into 12y, or I can turn 4 into a 12 by multiplying it by 3. So what I'm going to do is I'm going to leave the first equation alone. I'm going to leave it negative 2x plus 12y equals negative 30. And then I'm going to take the bottom equation and I'm going to multiply the entire thing by 3. When I do that, the first equation stays the same, negative 2x plus 12y equals negative 30. But the bottom equation becomes 3 times 3x is 9x, minus 3 times 4y is 12y. And then 3 times 17 is 51. Now what I can do, if you notice, I have a positive 12y and a negative 12y in my two equations. And what I can do is I can add both of these equations together, and my y's are going to be eliminated. Negative 2x plus 9x is 7x. 12y plus negative 12y is 0. They cancel each other out. And then I have negative 30 plus 51, which gives me 21. I can solve for x by dividing both sides by 7, which gives me x equals 3. Once I multiplied and got 9x minus 12y equals 51, it's the exact same thing as what we learned before. The new thing today is going ahead and multiplying one or both of the equations so that we can use elimination by adding or subtracting the two equations together. Now I take my x equals 3, and I'm going to plug in 3 for x and solve for y in either one of the equations. I went ahead and chose to use the second equation. Notice what I did is I went back to my original. I know that we multiplied it by 3 and it should be the same thing. It shouldn't be that big of a deal. However, from this point forward, I always want you to go back to your original equations that they gave you for the system. So go ahead and go back to negative 2x plus 12y equals negative 30 and 3x minus 4y equals 17. That way you just know that you're solving those two equations. So I plugged it into the second equation. 3 times 3 minus 4y equals 17. 3 times 3 is 9. Go ahead and subtract 9 from both sides, which gives you negative 4y equals 8. Divide both sides by negative 4, and you get y equals negative 2. I can combine these two to give myself the ordered pair 3, negative 2. Just like with before, we need to go ahead and check our answer by plugging in 3 for x and negative 2 for y. When I do that, I get negative 2 times 3 plus 12 times negative 2 equals negative 30. Well, negative 2 times 3 is negative 6, plus negative 12 equals negative 30, and that is true. Same signs, we would add the numbers, keep the sign, which gives me negative 30. Go ahead and check the second equation. Notice I am using the original second equation before I multiplied it by 3. Plug in 3 for x and negative 2 for y. You get 9 minus negative 8 equals 17. Well, 9 minus negative 8 is 17. So it works out. We checked our answer. The solution to this system is 3, negative 2. The next example says, what is the solution of the system? Use elimination. We have 2x minus 3y equals negative 12, and we have 3x minus 2y equals 2. Look at your x's, look at your y's. Notice both of them have different numbers in front of them. So we are going to need to multiply one or both of the equations so that we can use elimination. If you look at 2x and 3x, I can't multiply just one of those numbers to get the other one, so I would have to multiply the first equation by 3 and the second equation by 2 to give me 6x for both of them. If you look at the y's, they're not any different. I actually just have 3 and a negative 3 and a negative 2 in the other position, one with the y's and one with, negative 3 in the top equation and negative 2 in the bottom equation. So there's not really a better choice. We're going to have to multiply both of these. I chose to go ahead and eliminate the x's first, so I'm going to multiply the top by 3, and I'm going to multiply the bottom equation by 2. When I multiply the top equation by 3, remember I have to multiply everything. So 3 times 2x is 6x, minus 3 times 3y is 9y, and then equals 3 times negative 12 is negative 36. Go ahead and multiply the bottom equation by 2, which gives you 2 times 3x is 6x, minus 2 times 2y is 4y, and then 2 times 2 is 4. Now I need to either add or subtract. I'm going to be able to eliminate my x's because both have a coefficient of 6. I need to subtract these equations to get rid of my 6's. 6x minus 6x is 0. Negative 9y minus negative 4y equals negative 5y. Integer rules, make sure you're being careful. And then negative 36 minus 4 is negative 40. Divide both sides by negative 5, and you get y equals positive 8. Now I need to go, again, I'm going to go back to my original equations now. I'm going to plug in 8 for y and solve for x. It does not matter which equation you use. I chose the second one because it doesn't have a negative. It really doesn't matter either way. You have 3x minus 2 times 8 equals 2. Well, 2 times 8 is 16, so I have 3x minus 16 equals 2. Add 16 to both sides, and you get 3x equals 18. Divide both sides by 3, and you get x equals 6. So the ordered pair that I believe is the solution is 6, 8. Just like with all of my other problems, I need to go ahead and check my answer by plugging in 6 for x and 8 for y. When I plug that into the first equation, I have 2 times 6 minus 3 times 8 equals negative 12. 2 times 6 is 12. Negative 3 times positive 8 is negative 24. So 12 minus 24 equals negative 12, and that is correct. So it works for the first equation. Plug it into the second equation also. We have 3 times 6 minus 2 times 8 equals 2. 3 times 6 is 18, minus 2 times 8 is 16 equals 2. 18 minus 16 does equal 2, so that is a solution to the second equation also, which means it is a solution to my system. So the solution to this system of equations is 6, 8. This next example says a concession stand sold a total of 138 small and large popcorns. A small popcorn costs $2.50 and a large popcorn costs $4. Total popcorn sales were $466.50. How many large popcorns were sold? I'm going to go ahead and I'm just going to use S and L, S for small, L for large. You could define and say X is small, Y is large, or vice versa. Just make sure that you know what your variables are standing for. I went ahead and said the small plus the larges equals 138 because that's how many packages of popcorn that they sold. I also know that 2.5, which is the same as $2.50, I'm sorry. So 2.5 times S, because that's the cost for the small, plus 4 times L, because that's the cost for the large, equals 466.5, because that's how much money they made off of popcorn sales. I'm going to just go ahead and use elimination. To use elimination in this problem, I am going to go ahead and and eliminate my larges because it's going to be easy to multiply that top equation by 4. That gives me 4s plus 4l equals 552. And then the second equation stays the same. I have 2.5 times s plus 4l equals 466.5. I need to subtract these two equations to eliminate my L, or my large popcorn. 4s minus 2.5s is 1.5s. 4l minus 4l cancels out. And then I have 552 minus 466.5, which gives me 85.5. When I divide both sides by 1.5, I solve and I get s equals 57. Now I need to go back and I need to solve one of these equations for L. I'm going to choose the first one because it's going to be really, really easy. So I have 57 plus L equals 138. Subtract 57 from both sides, and you find that the large equals 81. Go ahead and check your answer. To do that, I'm going to plug in 57 for S and 81 for L. So 57 plus 81 equals 138. That is true. And then 2.5 times 57 plus 4 times 81 equals 466.5. Well, 2.5 times 57 is 142.5, and then plus, there's a subtraction sign there. That should say plus 324. I apologize for that. That just a typo. Equals 466.5, and that is also correct. To answer the question, it says how many large popcorns were sold. The answer would be they sold 81 large and 57 small popcorns. I just included the 57 small. But to answer the question, it would be 81. Just like with graphing and with substitution, sometimes when we're solving a system of equations, we will have no solution and infinitely many solutions. If you get a false statement when you're using elimination, like 3 equals 2, negative 6 equals 8, etc., there is going to be no solution. And if you get an identity, which is like 4 equals 4, negative 7 equals negative 7, etc., there are infinitely many solutions. These are the same rules that apply So when we were talking about solving equations by substitute, or solving systems by substitution. So if you get a false statement, it's no solution. If you get an identity, it's infinitely many solutions. How many solutions does the system have? We have 12x minus 8y equals 20, and then we have 3x minus 2y equals 5. If you look, I can multiply the second equation by 4 to get the same numbers in front of my variables. So I'd have 12x minus 8y equals 20 from the first equation, and if you notice, the second equation becomes 12x minus 8y equals 20. So I actually have the exact same solution, or the exact same equation on top and bottom. If you think back to when we were graphing and we had the same equation, we kind of knew something. But let's go ahead and look at this. When we go ahead and solve, I need to subtract to eliminate my 12x and 12x, or the negative 8y and negative 8y. When I subtract 12x minus 12x is 0. Negative 8y minus negative 8y also is 0. And then when you do, so we have 0 on this side, and then when you do 20 minus 20, you get 0. 0 equals 0 does not mean we have no solution. That is an identity, which means we have infinitely many solutions. Today's assignment is on page 402. It's numbers 1 through 20 all.